Here we go. All right, here we go. So question number 20, it says angle ABC is 22 degrees, which I've outlined in green. And then we have DBC. So I'm going to outline that one in pink. And it wants us, and I'm not going to outline all of these for every single one, but today for this question I will. It wants us to find ABD, which is the one in orange. Well, if we were to take the two insides, which are 46 and 22, we can add them together to get the total. Since this is a knowledge check, well, maybe we won't watch this video. Normally oh, here we go. All right, since it's a knowledge check, I will have her further explain it to you.
Given that the measurement of angle ABC equals 22 degrees, and the measurement of the angle DBC equals 46 degrees, determine the value of the measurement of angle ABD, which is the large angle here. So 22 plus 46 degrees equals 68 degrees. So the answer is D.
So they kind of looked at it differently, and that works perfectly as well. Oh, I better erase this for my next set of kids, huh? All right, so looking at question 21, I'll outline this, but I'm not outlining all of them, okay? So it says C is not on the line AOB, which automatically tells us that AOB, being a line, is 180 degrees, okay? Then we have this one right here, which is measure of COB. So COB is right here. And then we have AOC, which is right here, okay? And so when we look at this, we know that this whole entire line, which I can outline in orange here, is 180. So all you're gonna do is take 180 and subtract out 47, because you know the whole thing is equal to that, okay? Do we have any questions on that? Let me get her to play this for you. She's being real iffy today on if she wants to play. Let's see. Here we go.
Given C is not on a line AOB, and the measurement of the angle COB equals 47 degrees here, determine the value of the measurement of angle AOC here. So we know that if you have a line, a straight angle, and we know that this portion is 47 degrees, we can figure out what this is because it's going to be 180 minus 47 degrees, because we know that this angle plus this angle has to equal 180. So if we make this x, we could say that x plus 47 equals 180, therefore x equals 180 minus 47. So 180 minus 47 is 133 degrees. So that's our answer, B.
So you don't necessarily have to use x's in order to solve for these because these are fairly simple equations. Whichever way you do it right now is going to be acceptable. When there will be times where you have to put an x in it, but that time is not now. Another thing on this question that you could have looked at is you could have said if I drew a line straight up, that would make this 90 degrees. And I still have all of this left over. Therefore, that could never have been the answer. So by process of elimination, you can get rid of a few things. Oh my gosh, let me erase this. Looking at question 22, same concept here.
Given that the measurement of angle OLM equals 64 degrees, so that would be the large angle here. The large one is 64 degrees. And the measurement of angle OLN equals 53 degrees here. Find the measurement of angle NLM, which is just this little portion here. So if we know that the two angles here, here, and here added together equal the large angle, then we can set up an equation. So we know 64 degrees equals 53 degrees plus x. So this little portion is x. That's what we're trying to find. So So x equals 64 minus 53 gives us 11 degrees. So that is the measurement of this angle.
So another way to look at this, you could have said this entire angle is 64, and I just need to subtract out 53. Either one of those would have been totally acceptable ways to solve for this. I think that she kind of goes a little bit over the top on this, but sometimes over the top is good.
Given that the measurement of angle ABD equals 95 degrees, and that's the large angle from this ray over to this ray, and the measurement of angle CBA equals 48 degrees here, find the measurement of angle DBC, which is this angle here. So we have our large angle, 95 degrees, and that equals 48 degrees plus x here, this amount of degrees. And that's what we're solving for. The measurement of angle DBC is now x. So x equals 95 minus 48, which is 47 degrees. So x equals 47 degrees.
Okay. Looking at question 24. And again, you don't necessarily have to use x's to solve these. You can if you want.
Given that the measurement of angle KLJ equals 145 degrees, so the large angle here is 145 degrees, and the measurement of angle KLH equals 61 degrees, this here, find the measurement of angle HLJ, which is this angle here. We will call that x. So we know that 145 degrees equals 61 degrees plus x. Therefore, x equals 84 degrees. So 84 degrees plus 61 degrees gives us the full angle of 145 degrees.
So again, you could have looked at this and you could have said the entire thing is 145. I'm going to subtract out the piece I do know to find this piece right here that I don't know, which leaves you with that. Okay, so multiple ways to do this, and it's okay if you took the long road. In the long run, it's okay because you'll be ahead of the game. This question, this question is not for a grade. This is like a bonusy type question, but if you get it right, then you got a little bonus there.
Given that the measurement of angle TRS equals 3K minus J, so that's here in red, and the measurement of angle SRQ equals 4J plus 5K, that's the large angle in blue here, find the measurement of angle QRT here in terms of J and K. So we'll call this one X. So we know that 4J plus 5K equals the addition of this angle and this angle. So 3K minus J plus X. So let's solve for X. X equals, we'll move this 3K over there. That gives us 2K. This J over there makes that 5J. So the answer is 2K plus 5J degrees, C.
So that was a more complicated one. These questions I actually went ahead and drew for you prior to the knowledge check. So I can go ahead and do that again for you. That way you can look at them beforehand. So it says C is in the interior, so we know it's here. And then we have TUV. It says TUV, which is this entire big thing, is 10x. Whoop. And then it tells us TUC, which is right here, is 14x plus 18. And it tells us CUV, which is this little piece right here, is 9x plus 2. Well, we know if we take those two insides, we can set them equal to the outside. And it's going to look like that, okay? Here she goes. Oh my gosh, play.
C is in the interior of angle TUV. All right, so we have an angle like that, TUV, and C is, say, over here. So we're getting some information. The measurement of angle TUV, So the whole angle is 10x plus 72. Measurement of TUC, so this portion here, is 14x plus 18. And the measurement of CUV, so this angle here, is 9x plus 2.
So if you kind of look at how she writes it versus how I write it, that red angle that she put in there, I wrote that way out to the outside since it's the biggest angle that is on the outside. It doesn't necessarily matter which way you write it. I think it's easier to look at when you're looking at the red one being on the outside, but either way is acceptable.
X. All right, so we know that 10x plus 72 equals 14x plus 18 plus 9x plus 2. So that gives us 10x plus 72 equals 23x plus 20. So if we move these x's over here, we get 13x, and we put that 20 over here, we get 52. Therefore, x equals 4. The answer is A.
We are kind of nearing the end of examples here. I will go ahead and draw this one for you as well, which I did before you took the knowledge check. So we have this, and it says D is in the interior, so we know it's out here. Then we have A, B, and I don't know why it erases things sometimes. Oh my gosh. And C, okay? Then it tells us CBA, which is the entire outside, is 11x plus 66. It tells us DBA, which is right here, is 5x plus 3. And then it tells us that this angle right here is 13x plus 7. Well, we know from prior knowledge that the two insides, when added together, are going to equal the outside, okay? So she's going to solve now as well. Her way of solving it is a little bit difficult. I think she kind of just takes the longer route, and that's okay. Why is she not playing right now? Here we go.
D is in the interior of angle ABC. All right, so we have angle here, ABC, and we have D in the interior, so we'll say that D is over here. So we're given some information. If the measurement of angle CBA, so CBA is the whole thing, equals 11x plus 66 degrees, the measurement of angle DBA, so this portion here, equals 5x plus 3, and the measurement of angle CBD, this here, that is 13x plus 7 degrees. So let's solve for x. We have the full amount, which is 11x plus 66, equal to 5x plus 3 plus 13x plus 7. So we have 11x plus 66 equals 18x plus 10. If we move that over there, we get 7x. That over there, we get 56. Therefore, x equals 8. The answer is B.
All right, I think we have one more like this. I'll go ahead and draw it for you. So it says F is in the interior. So we know that F is the one on the inside, and it's DQP. And looking at this, we have DQP, which is the whole outside, is 3x plus 44. Then we have FQP, which is right here, is 8x plus 3. And DQF is 5x plus 1. We know that the insides added together will always equal the outside. And then from there, you are able to solve. Here she goes.
F is in the interior of angle DQP. So let's draw our angle. All right, here's an angle. And we have F in the interior. So there's F. Here's D, Q, and P. All right, if the measurement of angle DQP, so the large angle, is 3x plus 44, and the measurement of angle FQP, so FQP, this part is 8x plus 3, and the measurement of angle DQF, so here, if that angle is 5x plus 1, solve for x. All right, so we have the large angle is 3x plus 44 degrees equals 5x plus 1 plus 8x plus 3. All right, so we have 3x plus 44 equals 13x plus 4. So that would be 10x over here and 40 over there. So x equals 4. The answer is A.
Okay. So what we're going to talk about now is protractors. And protractors are a little bit to talk about because I don't have a protractor with me and you don't have a protractor with you. So that being said, this lesson will go pretty fast. And then we'll do the knowledge check together and watch the videos because we don't have a protractor and she has one in the videos. So this is a little bit more imaginative because we don't have the correct resources, but we're gonna make do the best that we can. So when talking about protractors, protractors allow us to measure angles in degrees. In Euclidean geometry, angles have a measure from 0 to 180. Angles can be drawn in any size, but to measure an angle may require extending lines to reach the scale of a protractor. So that thing that you can see kind of muted in the background, that is a protractor. And so here's another picture of a protractor. And they've drawn angle ABC on here, and they're telling us it's 23 degrees. How did they get that? Well, it's right here, shows you that it's at 20, and you can count 1, 2, 3, which leaves you with 23. Notice how they've written the measure of angle ABC is 23. It's important that you're putting measure in front of something when you were talking about the degree of it. So if we were in class, we would all have one of these objects, and it is called a protractor. Here's another example of a protractor. It says DBC is 18 degrees. So you could have gone to 110 and you could have counted all these little notches going this way, or you could have said, oh, I'm at 120 here, I'm gonna subtract 2. And that's why I'm left with the measure of DBC being 18 degrees, okay? So if you look back, we have ABC, which is the first one we did, and then we have DBC. Well, they've combined them here, and it says from our prior results, we know that DBC is 18 degrees and ABC is 23 degrees. So if we look at this, we can actually make this in color to help us. DBC, so DBC is this one right here in orange. And then we can do one in pink, ABC. So ABC is right here in pink. And then in green, they want us to find DBA. Well, we know based on the angle addition postulate that we can just take this 118 and subtract 23. That's one way of doing it. The other thing is we could have taken the very bottom of this protractor and we could have shifted it up until this line. So this line was at 0 degrees, and then we would have gotten a new measurement on the protractor, which is a way that we could have determined what the measurement for DBA is. So when talking about protractors, without the prior results, we could just read the values of 118 and 23 from the protractor and subtract to get the unknown. We also can rotate the protractor to get the results in a direct way, which means that we would have taken the protractor and just moved it up a little bit. So this is the knowledge check. Obviously, you're definitely not taking this knowledge check because you don't have a protractor. So if we look at this, let's kind of determine what we could do, and then we'll watch her video. So it wants CJD, so C to J to D. So we know that 90 degrees would be this one. So we don't have all of this. So we know that it has to be less than 90. So none of these could be our answer, okay? And it looks about like it's 90 cut in half. I don't know, but I'm gonna guess it's that one. It might not be that one. But by process of elimination, we can definitely get rid of 2 of our choices. And again, you would have a protractor to measure these.
What is the measurement of angle CJD? So CJD is this angle here. And we see it goes from 0 up to 39. So the answer is A.
So my guess was incorrect, but again, you would have had a protractor to check it. But we definitely knew that it was not anything that was greater than 90. So now we can kind of look at process elimination here. We have CJG. Well, that is so you're talking about this whole entire thing here. Well, that is larger than 90. Therefore, we can automatically eliminate those two.
What is the measurement of angle CJG? CJG is the angle that goes all the way like that. So this angle from here to here. And it goes from 0 all the way over to 130. So the answer is C.
Let me get this erased, sorry guys. Question 31, it wants DJE. Well, DJE, we look at that and that is pretty small. DJE is right here. So we know there's no way that it's gonna be that, right? It's pretty small. I'm not gonna guess which one it is because I already guessed wrong. Okay, well, come on, play. All right, here she goes. And again, all of these you need a protractor to do, which is why we're not actually doing this.
What is the measure of angle DJE? So DJE, this angle here. So we see that this line starts at 39 and it goes up until 54. So all you do is take 54, subtract 39, and you get 15. So this is 15 degrees here. The answer is D.
Okay, looking at question 32, you could also do process elimination. I'll go ahead and start this video since sometimes she doesn't like to play.
What is the measure of angle EJG? So EJG, that goes from here all the way over to here. So this here is at 54 degrees, and this line here is at 130 degrees. So we want 130 minus 54 to give us this amount in here. Because once again, we know that if this angle is 54 degrees and this entire angle is 130 degrees, then all we have to do is subtract this from the larger amount in order to get this green portion here. So 130 degrees equals x, which is the green amount, plus 54 degrees. Therefore, x equals 76 degrees. So the green area here is 76 degrees. Our answer is B.
Oh, there you go. So if you had a protractor, I think you could see how this would be rather simple.
What is the measure of angle DJF? So DJF, that is this angle here. So this is at 90 degrees, and this one is at 39 degrees. So if we just subtract those, 90 degrees minus 39 degrees gives us 51 degrees. So this area here is 51 degrees. The answer is B.
Another one. Again, we're going over all these because this is good practice and we don't have a protractor.
What is the measure of angle PJK? So PJK, we're looking at this angle right here. So we start at 0, we go up. There's this longer line here is 30. That's 31. And the blue line is right on 32. The answer is B. What is the measurement of angle PJM? PJM. So we're looking at this angle right here. So from here up to here. Now this right here is at 90 degrees, and P is at 0 degrees. So yeah, we could just look and say, oh, the answer is 90, which it is. You can also think of it like 90 degrees minus 0 degrees gives us an answer of 90 degrees. So the answer is C. And you can see that this is a right angle. From this line to this line, we could draw a little square there.
Okay, this one's a bit wordy. They are using process elimination on this one. We'll go over this one and then we'll skip the next one just because it's so long.
3 statements are true, 1 is false. Identify the false statement. All right, the measure of angle PJM, so PJM, that's 90 degrees, equals the measurement of angle OJM. OJM, that is also 90 degrees. Those are both right angles. So this is true. 2 times the measure of angle MJN. So MJN. So 90 to 135. So it's 10, 20, 30, 45 degrees. So 2 times 45 degrees is 90 degrees equals the measure of angle MJO. MJO is 90 degrees, so this statement is true. Measure of angle PJL. PJL goes to here, which is 63, and plus the measure of angle LJO. Oh, so LJO. So this angle from P to L up here, then from L all the way to O over here, equals 180 degrees. That is true because we're dealing with this portion and then adding this second portion that is the straight angle of 180 degrees. This is true. 3 times the measure of angle PJK. PJK, that is 32. So 32 degrees times 3 is 96 degrees equals the measure of angle MJP. MJP is 90 degrees. 96 does not equal 90. The answer here is D.
Okay, so that was a lot, and it's difficult without a protractor. We're gonna go ahead and skip this one. It's the exact same concept, but again, you would need a protractor. So now we're gonna start on special angles. And special angles we spoke about pretty briefly at the beginning of the school year back in August. And those are, special angles are kind of like they're complementary angles, supplementary angles, vertical angles, and things like that. So special angles tell you how to set up an equation. So the first one we're going to talk about is complementary. And complementary angles are 2 angles whose measure adds up to be 90 degrees. So if we look at the picture on the left-hand side, those are adjacent complementary angles. And we know that because they are right next to each other. If we look at the picture on the right, those are non-adjacent complementary angles. And we know that because they're not next to each other. Adjacent, this word right here, means next to each other. So if we read this little blurb at the top, it says one such angle is said to be the complement of the other. 2 complementary angles may be adjacent angles, but don't need to be. So, sorry, I thought that was the eraser. So we're going to kind of look at some theorems, and then we'll take a knowledge check, and then class will be over. Theorems are a little bit difficult, and they kind of, in a way, are very similar to proofs, which we'll talk about later. So the theorem says that adjacent complementary angles form a right angle. Well, complementary, this word right here, means 90, and adjacent means next. So if you have two angles right here that are right next to each other and they're complementary, that means they're gonna add up to 90. So that's how you automatically know. If you dissect that very first sentence, that helps you. So those of you that don't know your vocab, right here, this sentence, and this is actually our vocab too, there are 1, 2, 3, 4, 5, 6, 7 words in this sentence. And there are 5 of them that are from our vocabulary, which is what makes geometry really difficult if you are not doing your vocabulary. So if we look at this proof right here, we're going to just kind of look at the bottom part. It's talking again about adjacent complementary angles, and it says that ABD and DBC are complementary, which means right here that these equal 90, okay? What it doesn't do is highlight for us. So we can start with ABD. So we have ABD, which is right here. And we know if we add that to DBC, right here, this angle, they're gonna equal 90 together. Well, they don't just equal 90. They also equal ABC, because it's the same thing. Two insides are gonna equal the outside. We just happen to know already that they equal 90. Therefore, we can formulate this sentence based off of these two pieces of information. If together these equal 90 and together they equal that, we can pull the two pieces of what they equal together and say that ABC, which is the orange one, is going to equal 90 degrees. Theorems are a little bit complicated, but we're capable of doing them. So right now you have a knowledge check, and I will give you 10 minutes to do it. Let me look up exactly what the knowledge check is. It is called Special Angles 38 through 41. And I'm going to type it in the chat. It's important that you're doing that one. There's two that are called special angles, but it's the 38 through 41 one that you're supposed to be doing right now, okay? So 38 through 41 is what you're doing, and I'm gonna stick you in a breakout room. If you are confused in the chat, it tells you also what you are doing. So here you go to your breakout rooms. I'll call you back at approximately, I'll call you back at 2:05, okay? So you should be headed to your breakout rooms.
Hey, Miss, it says I already did it, but I don't remember doing it.
Well, you
Okay.
definitely should not have already done it.
I don't know, Miss. Like it just said, like, I swear to God, I've never done that.
Okay.
I swear to God.
I'll reset it for you. Give me 1 second. It's going to take me a minute to find it. All right, give me 1 second, Marco. We're getting closer. I found it. Now I just got to find you. The rest of you guys should be in your breakout rooms. If you're watching this recording, you can pause it, take this knowledge check, and then fast forward through this part until the end. All right, Marco, you should be able to do it now. So Julio, David, Dianara, there's no reason that you should be in here. You should all be in your breakout rooms. The only reason for you not to be in a breakout room is because you're not paying attention right now. Hey guys, welcome back. We've got about 1 minute before everyone joins us, and then we will go over this knowledge check. All right, so about 30 seconds till the rest of us are back in here, and then we can get started. Hopefully you are staying warm with the snow. Well, a lot of you are still in your breakout rooms. Let's see. All right, we got 9 more seconds. All right, perfect. So we're gonna go ahead and go over this. What is the measure of a complement of an angle? Well, as we just discussed, a complement is 90 degrees. So the complement to 72 would just mean you subtract these. Okay, she does this a much more complicated way. The subtraction way is appropriate. Her way also works. Whichever way you wanted to do it works, but complement means 90.
What is the measure of the complement of an angle whose measure is 72 degrees? All right, so we have an angle here, a right angle, and we have a line like this, and we know that this portion is 72 degrees. Then what is this angle here? So because we know that the entire angle is 90 degrees, that would be x plus 72 degrees. Therefore, x equals 18 degrees. A. This portion here is 18 degrees. Add that to 72 degrees, and we get the full right angle, 90 degrees.
All right, looking at question 39.
What is the measure of the complement
Oh, where did our volume go?
angle? And we know that this angle here is 28 degrees, and we want to know what this angle is here. So the full angle is 90 degrees, and that equals x plus 28 degrees. Therefore, x equals 62 degrees. The answer is B.
All right. Question 40. So this is kind of like backtracking. So if we drew a picture of this and we know that together these are 90 degrees and this one's x, and we don't know this, you could take 90, which is the whole thing. If you're not muted, make sure you mute yourself. Take 90, subtract x, and you would find what's left. Okay, 1 second. I'll just keep. Okay, here we go.
What is the measure of the complement of an angle whose measure is x degrees? All right, so we have our right angle, and we have a line like that. And if this portion here is x, then this portion here is what we're solving for. I'll call that y. All right, so y equals the full angle, 90 degrees, minus this portion here, x. So the answer is 90 degrees minus x. And that is how we find the measure of the complement of any angle.
Okay. Looking at the next one. This one is probably the most complicated one of this.
What is the measure of the complement of an angle whose measure is 3x plus 20 degrees? Okay, let's draw a picture. Here we have our right angle. This angle here is 3x plus 20 degrees. And we'll say this angle here is y, and that's what we're solving for. So we have 90 degrees, which is the full angle, equals y plus 3x plus 20 degrees. And if we solve for y, that gives us 70 degrees minus 3x. And so that is 70 minus 3x degrees, and that is A.
So she took the total, which she knew was 90, and then subtracted just this piece out because that's what would be left over, which is where they came up with that 70. All right, so you are good for today. Class is over. We're gonna go over these examples next class, have another knowledge check, and then we'll also learn about supplementary.